So again, your tests are in Canvas already. They did pretty well. If you want to do something, if you want to add to that, you can. You know, retakes are always available. So, but if you need to do that within the first week, okay? And if you weren't happy with what you got. So. Linears, remember linears equations? So pretty straight up, you know, a linear might be something like 2x plus 3 equals 10, okay? Just a simple single variable equation is what we're talking about. Take the 3 over, divide, you know, simple stuff today, okay? So we're gonna solve some of those and some inequalities. An equation is a mathematical statement. If you, again, as I talked about before, write what you want. You don't have to go too far. What's an equation look like? Very simple one. 2x plus 5 equals 13. Of course, we can have a lot more complex equations. We can have 2x to the second power minus 2x plus 10 equals 30. Be quadratic. So it has an equal sign in it and a variable, okay? But the equation has an equal sign and a variable. Our solution set can be many things. That solution set can be one value. It can be many values. We've used a couple different methods. We use set builder and interval notation to write a solution that's more than one. So we're going to do that again today. So solutions can be more than one, and we'll use set builder, and that's why we did that. So there's your standard linear ax equals b, which again, 2x can be as simple as 2x equals 10. Okay? So your a and your b are numbers, and your x, 2x equals 10. Very simple. So this is really kind of algebra 1, going way back. Some simple algebra stuff. Everybody okay there? All right. Some ideas is these are linears, 4x equals 8. We can have fractions, that's fine. Simple fractions, we can have decimals, not a problem. Okay? We're not going to have radicals in a linear. This is a radical equation. We're not going to have fractions here where the variable, we can have fractions like this over here, 2/3. But the variable, the x is in the denominator, not going to happen. This would be a rational. Okay? That's a radical, rational. And this third type here is an exponential. Notice the unknowns in the exponent. We're going to get to those. We're going to do 1, 2, and 3 later on in the year. We're going to have those equations. But for now, we're just looking at these linears. So again, linears, real simple. We've already looked at something like that. It can have a fraction, not a problem. But notice the variable x is not in the denominator. X is in the denominator over here, which makes it non-linear. Decimals are fine. Okay. So just a couple visuals of what linears, equations, one variable. Okay. Everybody okay there? It's Thursday, isn't it? It's getting closer to the game. I think the Browns play tonight, do they? How about that? I might even watch a smidge of it, but not too much. Be on really late, and I'll probably fall asleep as usual. Now, I wouldn't write this down because this is stuff that you already know. We're going to solve simple equations. Number 1 would be whatever you add to one side, you add to the other. Whatever you subtract from one side, you. Okay. If you multiply one side, you. If you divide one side, you divide. No need to write that stuff down, is there? Okay, let's try a couple. Put these into play, I think you'll be fine. Might need to use the distributed property first and see if we can solve for M. Thank you. So we'll distribute, get 4M plus 48, negative 36. Now we're ready to do whatever you do to one side, do to the other. Minus 48. Minus 48, so now we're down to 4M equals negative, I think that's 84, if my math is correct, is that right? Yes. So now we're gonna divide by 4, of course. And we're ending up negative 221. Simple stuff. How do you feel about that? I think everybody should feel pretty good about that. I'm not gonna go too many of these. Is everybody okay? Let's try with just one more, and then we'll go on to the next thing. Let's do this bottom one down here, because it's got some negatives in it, and see if we can handle that one right there. Distribute, watch your negatives. We're gonna get negative 15, that's gonna become plus 12R is equal to 9. Now don't distribute it to that 9, it's only these guys right here, hopefully we do that. All right, let's get the numbers on one side. I'm gonna plus 15. And then I'm down to 12R. Looks like it's equal to 6 over there, isn't it? Positive 6. Whatever I do to one side, do the other, I'm gonna divide by 12 now. And then down to R. Equals 6. Enough of that, everybody? I think we're all right. Okay? That's pretty easy stuff and should be fine. All right, let's see if we can write and solve a simple algebraic problem. Here's where really the rubber meets the road. A phone company can charge $12.95 a month for the first 200 air time, plus $1.07 for each additional minute. This is back in the day when cell phones first came out. This is how they charged you. You guys weren't even born yet, probably. That's okay. So let's look at some numbers. We got this number, it looks like it might be important. This number might be important. This guy is important. This really means nothing, okay? It's just a number there. So you gotta get through what's important and what's not. Now, when you're writing equations, I always look for a total. When I look for a total means equal to something. What is our total that we're really looking at here? This is 1456. Okay, that's our total that we're paying. Now, this is very similar to the other day, we had one of these, didn't we? Okay, so I have an initial amount, plus what are we being charged? 0.07, here's where our variable comes into play. It can be X, but we're gonna go ahead and put M because that would be the minutes. Now, of course, there's decimals here, so I certainly would grab my calculator myself. I wouldn't be able to do this in my head with the decimal negative. So take a shot at that. And first thing we're gonna do is subtract 12.95 from 14.56. And then, of course, divide by 0.07. And she overpaid a little bit because she went over how many minutes? 23 minutes? 23, one of the most famous number in all of basketball, 23. Writing a simple equation, how are we there, my friends? Questions? Moving on. This is that question. Now we're going to skip the cups question. And we're going to go right to this guy right here. A little harder. Same concept. Collect everything on one side and see if we can solve. This is just a little deeper, a few more terms. And we're going to add them up. Get all the variables on one side, get the numbers on the other, and simplify. So it really doesn't matter where we get the k's, but most of the time we'll start by getting things together over here. So negative 11k plus 25. Over here we'll get the minus 6k. Adding our numbers, we're going to get negative 10 there. Again, doesn't matter which way we go with the numbers or the k. I'm going to go ahead and plus 6k over here. So plus 6k. And I'm going to end up with what? Negative 5k. I'm going to minus 25 on this side and minus 25 over here. Still have my equal sign, and now I'm going to be negative 35 over here. So again, another simple problem. Divide by negative 5 now. And you'll finish up. X equals 7. Questions there? Everybody okay? All right. There is all this rigmarole here, and you can read it on the PDF if you want. But all it means is this. If we end up with a false statement, that is false there, by the way. 5 equals 3. Sometimes some of these equations and x's they'll all be gone. We end up with a false statement. If we end up with a false statement, there'll be no solution. So make yourself a big note and write it big enough so you can see it. Maybe even bigger than what you've been writing. A false statement, there are no solutions. There are no numbers that would satisfy this equation. It's a false set. 3 equals 5. That's false. When it's false, there are no numbers that would satisfy the equation. So if that's the case, what's the other option that can possibly come up? False is one option. What's the other side of false would be? True. So if we get a true statement, what if we ended up with 5 equals 5? What if we ended up with 5 equals 5? When you have a true statement, then my solution set is going to be all reals. True statement, all the reals. And I'm hoping you're writing this down, because this is really the main thing today right here that might not be in your memory banks. From Algebra 1. You know what I mean? So, let's put one of these into play. What do you think the next question is gonna be? Probably something that is either false or true, so let's see what we can do with this guy right here. We'll do just one of these, because it's already the same skill we've been doing. We're just gonna end up either being all the reals, a true statement or a false statement. I designed it, but be careful with that negative, we gotta distribute him. Add like things on this side. Negative b minus 9. Distribute that, we're gonna get minus 5 minus b. So we're gonna distribute that guy there. Now, yowza, sound like a lamb. I'm gonna add b, right? What's gonna happen when I add b to both sides? Okay, I'm gonna end up with negative 9 equals negative 5. And that is, of course, false. So do I have, are there any numbers we can plug in here to satisfy this thing? No, there's nothing. Okay? Of course, if it was true, it would be all the reals. Now, on a side note, this is also true for inequalities. What if I had negative 9 is greater than negative 5? Think about that. Is that a true statement or a false statement? Is negative 9 greater than negative 5? That is false. So this would be no solutions. But if I had negative 9 is less than negative 5, that would be true, isn't it? And that would be all the reals. So the inequalities, and we're going to do inequalities next, that is also true for those. Let's get to that inequality. What's the one thing about inequalities that we must do? And that is the only thing different if we add, subtract, multiply, and all that stuff. But when we divide by a negative number, of course, you remember this from 7th grade algebra, right? About 7th grade math, probably, right? You have to do what to that inequality? You switch it, okay? So you're going to flip that inequality sign if we divide by negative. All right, here we go. Now, second main point, you got the true and false. The second point that I really want to emphasize is graph. There are a couple ways we can do a graph. Now, when this word says graph here, that means a number line. Look up here, everyone. How many variables are in this equation? Just one, A. They're separated, but we'll put those together. When it's one variable, that's a number line. It's different than a Cartesian coordinate system, x, y. You have two variables. Hello, does everybody understand that? Also, we can do set builder, and we can write it in interval notation too. So we're going to do this problem now. Go ahead and solve on out, get an inequality. We're going to write it in a number line. We're going to do set builder, and we're going to do interval for it. So get everything on one side. Sometimes you might. Now, some teachers will teach you, to get the variable on the left. That way when you read it, it sounds right. And that's fine. So if you want to go that route, I'm going to subtract 13a because we want to get the variable over here. That is going to create a problem. We're going to have 5a, which is going to be negative. If I plus 2 on both sides, I'm going to get 5a greater than or equal to 10. So a lot of teachers teach it that way. You get the variable on this side, that way you can read it and it properly makes sense to you. Is everybody okay? This did give me another problem. It makes me have a negative over here because now I'm going to divide by a negative 5. So in doing so, I'm going to have a on this side, but now since I divided by negative, I need to switch the inequality. And 10 divided by negative 5 gives me negative 2. So this helps me read it properly. A has to be what? Less than or equal to negative 2. So it is good to get your variable on your left. Now let's go ahead and draw that number line. No need to do much detail. The only real number I'm interested in is what? Negative 2. I don't really need to put 0 and a bunch of other stuff in there. Just put the one number that we're interested in, negative 2. So what's it have to be? See, it has to be less than. So, and also equal. So we're going to fill that guy in. And we're going to head this way because that's where less than negative 2 would be, wouldn't it? Now if it makes you feel comfortable, put 0 in there. That's fine. You can put positive 2 up here if you want to add a little color to your line graph. Everybody understand why this is not a XY coordinate graph? Okay. Set builder. Set builder is already ready for us. A, such that A has to be less than or equal to negative 2. It's already set up for us, isn't it? Remember set builder? We get that inequality. We just plug it right in there. Bingo. Interval. Love interval because especially with a number line, which makes it pretty easy. Okay? I'm coming this way from negative infinity. I'm going to negative 2. Is it included? Yes, it is. There's your 3 ways to write a large solution set. It's not x equals 2, x equals 5. It's x equals all these numbers beyond this side. That's why we learned. That's why we learned back interval rotation, set builder notation. Get that right. One more and we'll call it a day. Is that fair, everyone? Mm-hmm. All right. Let's see if we can roll this one out. Whoops, I know what happened there. Trying to go up, but there we go. Where am I at? All right. All right. I want you to write a number line. I want you to do set builder, and I want you to do interval. Write the solution set. Solve. Write the solution set in those 3 types. So it looks like A needs to be what? Greater than or equal to 4. Did I do my math right? Everybody else get that? Give me a second to Finish your 3 ways. And my number line ready. So it is 4 and it is equal, so we're gonna fill that in. And we know it's greater, so it's gonna be everything headed this way, isn't it? There's your graph. Method 1, graph. Method 2, A such that A has to be greater than or equal to 4. Set builder. How are we feeling about this? Everybody okay? Method 3, coming 4, comma, 4 is included, going to positive infinity, and it is not included. If it's a true statement, what's it gonna be? The answer is, if it's a false statement, no solution, and that holds true for inequality as well as equal signs. You guys are great today, thank you so much. We're gonna skip a couple more, and then 18, 19, and 20 are some inequalities. 22 through 36 are just some simple equations, equal signs in there, so. Thanks again.